So what I want to do in this video is answer a student's question, and the question that I want to answer for him is he wants to know why the sine of x prime is equal to the cosine of x. So in the process of proving the sine of x is equal to the cosine of x, what I will need is I am going to need this is what I want to prove. I am going to need these two facts, namely that the limit of delta x as x approaches 0 of sine of delta x over delta x is equal to 1. I will need this. I will need this. I will also need that the limit of delta x as x approaches 0 of 1 minus cosine of delta x over delta x is equal to 0. And then I will also need this this identity, namely that the sine of x plus delta x is equal to the sine of x plus the cosine of times the cosine of delta x plus the sine of x times the cosine of delta x. So I will be needing this identity. So in order to make you understand that the first identity is not far-fetched, not the first identity, rather the first limit is not far-fetched, what I'm going to do is I'm going to take a little trip to Wolfram Alpha for now. This is not the way I'm going to prove this in the future, but for now it will be sufficient to do that. So here, I plugged in earlier, I asked Wolfram Alpha, I went into Wolfram Alpha, which is www.wolframalpha.com, and I asked Wolfram Alpha to plot for me sine x. I said plot, and then parentheses, the wiggly parentheses, the bracket. I said plot sine x divided by x, comma 1 minus cosine. Oh, sorry, I was supposed to put an x in here. I'm glad that I caught that. Not that it mattered actually, but I have to put Wolfram Alpha as a sort of a program that knows when you make mistakes and corrects them for you. But that you should not depend on that all the time, because you might end up with a bridge that collapses the first time it's open. So here it is. So now Wolfram Alpha has plotted this for me. Let me actually ask it to plot it again, and as you see, it's plotting it for me, right? So let me actually look at it over here. So we know that sine x over x is the blue line, the blue graph that I am tracing right now. Now look what happens as x approaches 0 to the graph. It goes right to 1. In fact, this function is continuous at x equals 0, and the same thing happens over here. Now let's look at the graph of 1 minus cosine x over x. Now this is the burgundy graph. As x approaches 0, as you notice that the graph goes through 0. We obviously can see on these graphs that certainly the limit as x approaches 0 of sine x over x is going to be equal to 1, and we can see that in the blue graph. And then the limit as x approaches 0 of 1 minus cosine x over x is actually equal to 0. So there it is. So now I have convinced you that the limit as delta x approaches 0, this is equal to 1. Sine of delta x over delta x is equal to 1. The limit of 1 minus cosine delta x over delta x as delta x approaches 0 is equal to 0. We saw that on the graph, and it's not a proof that I gave you, but for this presentation it will be fine. Now I want you to believe that the sine of x plus delta x is equal to the sine of x times the cosine of delta x plus the sine of x times the cosine of delta x. So now that we have done that, we're going to go to the next page and begin the proof, of this fact. Okay, so let me actually remind you of the definition of the derivative. Okay, so the definition of the derivative, as you recall, is that sine, okay, of x prime, right? The derivative of sine of x, this is equal to the limit as delta x approaches 0, right? Let me make this 0 look more like a 0, not a point, right? Of sine of x plus delta x, okay, minus sine of x, divide this whole thing, right? Divide this whole thing, I'm dividing this whole thing by delta x. So this is it. Alright, fantastic. Okay, so that is the definition of the derivative. Okay, that is the definition of the derivative. Let me actually box it up so that we know that we are using this fact, you know, which is the definition of the derivative. Now, if this limit exists, if the limit of this expression here exists as delta x approaches 0, then the function, okay, sine x will have a derivative, okay, everywhere where this limit, you know, exists. All right. So so now what I want to do is I am going to expand this over here, okay? But fortunately, I know what the expansion of this is, so I'm just going to write the equal sign over here. I'm not going to bother to write the left-hand side. I'm just putting the equal sign here, so equals, right? So expanding this using this identity here, which I did not prove, I am going to get, okay, I am going to get that this is equal, the top part over here, this stuff here, okay, is equal, this top part is going to be equal to sine of x cosine of delta x, right, plus cosine of x sine of delta x. And you know what, let me just put this in parentheses, because this is really what I did. I expanded this, and then I'm subtracting from that minus sine x. And I have a minor problem here because I'm really dealing with a limit, so I really should not have written this over here as an equal. I really have to put in here, sorry, I forgot to put that, I really have to say in here the limit as delta x approaches 0. You see, I forgot to put this thing here. This belongs in here. Okay, sorry about that. Okay. All right. So here I have that, but I also have to divide this whole thing by delta x. So there it is, divided by delta x. So now, now what I am going to do is, okay, what I'm going to do is, I am going to rewrite this. I'm going to rewrite this as, I'm just rearranging these terms over here. So what I'm going to write is that I'm going to write here cosine, okay, of x sine delta x. So I'm going to rewrite this whole thing, cosine x sine delta x, then I'm putting this over here on the other side. So this is going to be plus sine x cosine delta x, and then I'm just going to write here minus sine x. Okay, bravo. All right, very good. So now what I'm going to do is, notice what I have here. okay, notice what I have here. Oh gosh, I keep forgetting putting limit delta x as x approaches 0. Sorry about that, people. I have to write in here, okay, this thing here. So limit delta x, limit of this as delta x approaches 0. So there it is. So what I'm going to do now is I am going to, so this over here, I'm going to continue rewriting this whole thing. I'm going to rewrite this. Notice that I'm not taking the limit as x approaches 0. I'm taking the limit as delta x approaches 0. So I can actually move the limit delta x as x approaches 0 past the cosine of x. So I'm going to write this here. I'm going to write here. So this is going to be equal to cosine of x times the limit, okay, as delta x approaches 0 of another silliness here. I forgot to divide this, okay, by delta x. Okay, so I'm writing here sine delta x divided by delta x. And what I'm going to do here is that I'm going to take out minus sine x completely and do the same thing that I did over here. So this is going to become minus sine x. I'm factoring out minus sine x from here, and then I'm going to do the limit using the same type of reasoning as delta x approaches 0 of the expression, okay, minus cosine delta x, okay, plus 1, and I am dividing this, okay, I am dividing this by delta x. Really, if you analyze the situation here, all I did was that I rewrote this. Okay, I rewrote this in this fashion. Okay, of course, this is really nothing here. This over here, let me actually change the color. This over here, this thing over here is nothing but 1 minus cosine delta x over delta x. The limit of this as delta x approaches 0. Well, we know from over here that this over here, 1 minus cosine of delta x over delta x, the limit as delta x approaches 0, this is going to be equal to 0. Okay, so really, this is really equal to 0. So this is minus sine x times 0. Well, obviously this whole thing, okay, is going to be equal, okay, this whole thing is going to be equal to 0, and that's quite positive. But now we have here sine delta x over delta x, and I'm taking the limit as delta x approaches 0. Well, if you look back over here, I said that the limit as delta x approaches 0 of sine delta x over delta x is equal to 1. So clearly this equals 1, but then you have a cosine of x in front of it. So really, this whole thing translates into what we wanted, namely that sine of x prime is equal to cosine of x. The student that sent me the email asking me why this was true was named John. So John, that's how this works. This is why this works. Okay, so thank you for listening, and see you in class.